So, hello everyone. We are back again with the another session of our GRE. Today, as in I was telling you that in the next session we were supposed to discuss about the application of time and work. So here we are, and the application of time and work is called as just a moment. Okay. So it is called as pipes and cisterns. So pipes and cistern is something which is nothing but the application of time and work, which you might have heard about, which you might have heard lot many things about. And pipe and cisterns is something which, uh, I mean, they will ask you about the questions of pipe and cisterns. So let's just not wait for more and start. So pipes and cisterns. Let's get on to the terminologies which comes up. As I was telling you that pipes and cisterns are based on the basic concept of time and work. So it is not so different from what time and work is. The way of solving question would remain same in this case as well. So here, just a few things are there and a few additions are there, and this would be the first thing. So pipe are connected to the tank or a cistern are used to fill or empty the tank or the cistern. When it comes to filling the tank or emptying the tank, there are two different things which wherein you may call those pipes as. Okay, so here let's move little ahead. In pipes and cistern, the work is done in the form of filling or emptying the cistern or the tank. Inlet pipe, it fills the tank, wherein it is the inlet, and the outlet will empty the tank. Okay, here's the outlet pipe, which empties the tank or cistern or reservoir. Just a moment. Okay. So basic important points which comes up with the pipes and cisterns is if a pipe can fill a tank, fill or empty a tank in m hours, then the part of tank filled or emptied in would be in 1 hour would be 1 by m. For example, see, if at times, a pipe can fill a tank, fill or empty a tank in 7 hours, then the volume of tank filled or emptied in 1 hour would be this this much, 1 by m. Okay, that means 1 by 7. So next would be, if a pipe can fill or empty a tank in 1 by m hour, then the part uh, then it can fill or empty the whole tank. Okay, then it can fill or empty the whole tank in m hours. I'll just there is some I believe there is some um, glitch onto this. Just a moment. Okay, now that's it. Okay. So it says, if a pipe can fill or empty a tank in 1 by m hours, then it can fill or empty the tank in m hours. For example, if a pipe is taking 1 by 5 part of a tank in 1 hour, filling a 1 by 5 of a part in 1 hour, then it will take 5 hours to fill the entire tank. So it's just vice versa. Okay, as in we were doing how much time would A take or would B take or XYZ person will take. So that's why. Generally, the time taken to fill the tank is taken positive, and time taken to empty the tank is taken negative. So you have to keep this thing in mind. Now, if a pipe fills a tank in m hours and another pipe fills in n hours, then the part filled by both of the pipes in 1 hour would be m 1 by m plus 1 by n. Okay, so for these things to understand in more better manner, we have uh, we have some examples onto these. Okay, okay. So first example says an outlet pipe can empty a cistern in 5 hours. In what time the pipe will empty the empty part of the cistern? Sorry, here there has to be something else, which is uh, how much time will it take to empty the two-fifth of the part of the cistern. So here time taken to empty the two-fifth of the part of the cistern is equal to 2 by 5 into 5 is equal to, that means 5 hours to empty the entire cistern, so that this would become 2 by 5 into 5, that is nothing but 2 hours. So 2 by 5th, just to empty do the 2 by 5th part of it, they will take 2 hours. Okay, now another question comes up, and it says, if a pipe can fill a tank in 2 hours and another pipe can fill the same tank in 6 hours, then what part of a tank will be filled by both pipes in 1 hour if they are opened simultaneously? So in 1 hour, suppose the part filled by first pipe would be 1 by n. That is nothing but 1 by 2. And in 1 hour, part filled by the second pipe is nothing but 1 by n, which is 1 by 6 hours. So, when it comes to find out how much part will they fill in 1 hour, we have to add both 1 by m and 1 by n together. So this will become 1 by n plus 1 by n is equal to 1 by 2 plus 1 by 6, which gives me answer as 2/3 of the part of that tank. Okay, two-thirds of the part of the entire tank will be filled in 1 hour. Now let's move on to the next question. If a pipe can fill a tank in 5 hours and another pipe can empty the tank in 10 hours, then the part filled by both pipes in 1 hour would be if the both pipes are opened simultaneously. Okay, so here both pipes are both pipes are opened and they have to empty the tank. Okay, one is going to fill the tank and another uh, pipe or another tap or another pipe will be emptying the tank. So for that reason, we will be just rectifying the formula, and the formula will now become, okay, in 1 hour, part filled by both pipes when open simultaneously would be 1 by m minus 1 by n, because another pipe is emptying the tank. That is why we have taken minus onto it. Now let's put on the values. 1 by m would be 1 by 5 and 1 by n would be 1 by 10. Okay, this gives me answer as 1 by 10 only. So 1 by 10th part would get emptied. Okay, so if both of the pipes are open. So that much is the only part. Okay, let's move a little more ahead with the another example. But before that, there is something which you should keep in mind. So let's move on to that. Now mind it. You cannot leave this off. So if a pipe can fill or empty a tank in m hours and another pipe can fill or empty the same tank in n hours, then the time taken, if both the pipes either fills or empties the time taken to fill or empty the tank when both pipes are opened will be T is equal to Mn by M plus N. T is equal to Mn by M plus N. Now, this would be the direct formula when it comes to solving these kind of questions. Another thing, if first pipe fills the tank and second pipe empties the tank, then the time taken to fill the tank uh, when both pipes are opened will be T is equal to Mn by M minus N, because one is emptying the tank. Now this will become wherein M is greater than N. Okay, but when in case of M, N is greater than M, that means the another pipe is emptying the tank in just no time and M is taking the longest, then here is the another formula, sorry. So if the first pipe fills the tank, second pipe empties the tank, then time taken to empty the tank when both pipes are opened is T is equal to Mn by N minus M. Wherein I was telling you the second pipe would be taking lesser time than the first one, so that it will just empty the tank rather than filling something with filling it with something. Okay, so it will just empty because it is not taking any of the time, not even the smallest of the time, not even the fractions of the time, and the first tap might take the longest. So for that matter, this is the only way to find out the answers. Now let's get on to the examples based on this. So first example says two pipes A and B can fill a tank in 18 hours and 12 hours respectively. If both pipes are opened simultaneously, how much time will be taken to fill the tank? So here we'll just put the formula. Time taken to fill the entire tank, because here no one is losing anything. So here the formula would become time is equal to Mn by M plus N. So let's put on the values into it. 18 into 12 by 18 plus 12 will give me answer as 36 by 5, which is nothing but 7 into 1 by 5. Okay. After solving these equations, you'll get this answer as 7 into 1 by 5, or simply 36 into 5, 36 by 5. And that's it. Now here, why are we taking these many things? We can solve it through the longest also, when we will be just taking 1 by 18 plus 1 by 12. We can do it that way also, because uh, we are just doing cross multiplication and finding the answer out. Here also we are if at all we are just putting down 1 by m plus 1 by n also, then also it is just the cross multiplication which we are doing. Let's move on to the another example, which says a pipe can fill a tank in 5 hours while another pipe can empty it in 6 hours. If both the pipes are opened simultaneously, how much time will it be taking to fill the tank? So here, let's put the formula. Because as in we are seeing n is greater than m. So we have to put the last formula, which says mn is equal to n minus n. So here mn, that means 5 into 6 would be 30 by 6 minus 5 would be 1. So here it would be 30 hours simply. What I've just done is I've just put down the values in the formula and find out the answer. Okay. Now here there is another thing which you should keep in mind, and the thing is that if three pipes are there and they are filling three different tanks, okay, if they are filling three different tanks, and just a moment, and in 1 hour they are taking all the pipes are opened, and in 1 hour they'll be filling 1 by m plus 1 by n plus 1 by p, okay, as in three taps. So, and the time taken by them to fill the entire tank would be mnp by np plus mp plus mn. Okay, now let's get on to the example based on this one, and we'll tell you something after the example. Okay? Just to make this understand in a more better manner, we are solving the example. So here is the example which says three pipes M, N, and P can fill a tank separately in 4 hour, 5 hour, and 10 hours respectively. So M will take 4 hour, N will take 5 hours, and P will take 10 hours. Simply. Now find the time taken by all the three pipes to fill the tank when the pipes are opened together. So part filled by m plus n plus p would be 1 plus 1 by 4 plus 1 by 5 plus 1 by 10. Cross multiplication will give me answer as 11 by 20. Okay. Cross multiplication will give me answer as 11 by 20. Okay. Now if this is 11 by 20, so time will be exactly opposite uh, of what we have got. So time taken would be 11 by, sorry, it's 20 by 11. I'm really really sorry, it's 20 by 11. Which is nothing but 1 into 9 by 11 hours, which is like but 1 into 9 by 11 hours. So that's it. This is something which is filling the part in that too in 1 hour. And this is the entire tank. This is about the entire tank. So for that. Now part says 1 by something, and this entire would be the entire one. So now here there is something which you should keep in mind. If at all any of the pipes are used to empty the tank, then the time taken by the particular pipe will be negative. As in, suppose the third pipe, that is P, is used to empty the tank. Then the previous formula, which we have just seen, wherein M, N, and P was there, so that will take another form, which would be 1 by M plus 1 by N minus 1 by P. And the time taken by them would be MNP minus NP minus MP, sorry, plus MP minus MN. MNP by NP plus MP minus MN. So this would be time taken and this would be the just a formula. Okay. So yeah, this is by 1 hour and this is the entire time. Okay. Now let's get on to the example based on this. And here it says a pipe A can fill a tank in 20 hours, pipe B can fill it in 10 hours, and C can empty it in 30 hours. So if the pipes, all pipes are opened, how much time will it take to make the tank full? Let's get on to the direct formula. To fill the empty and to fill the entire tank, formula says MNP by NP plus MP by minus MN. So let's put the values into it and find out, which is 20 into 10 into 30 by 10 into 30, 20 into 30, and 20 into 10. So simply 66,000 by 700, which is nothing but 60 by 7, which is simply 8 into 4 by 8 into 7 by, sorry, 8 into 4 by 7. Okay, so this is how we are supposed to find this. So pipe A and pipe B both are filling the tank, but pipe C is emptying the tank here. And as in we are aware what is M, what is N, and what is P. So we have just kept the values in the formula and we have found the answer. That is it. Simple. That is why I'm just telling you the direct formulas, just to get you through multiple and various types of questions. Now here comes the another question which says two pipes A and B are opened together to fill a tank. Now both pipes fill the tank in time t. Okay, both pipes fill the tank in time t. If A separately takes 4 minutes more than t to fill the tank and B takes 64 minutes more than t to fill the tank, then find the value of t. As in we were finding it in the previous topic, the way we have started with time and work, there we have done t is equal to root ab. Here we are doing the same thing. Okay, the time taken by both the pipes to fill the tank would be root ab. So here root ab will be a is 4 and b is 64. So let's multiply all of them together, both of them together, and we'll get the answer as 256. 256 is the root of 16, so that uh, this time t is nothing but 16 minutes. So B will take 4 minutes more than 16, that means 20 minutes. And sorry, A will take more than 4 minutes more than 16, that means 20 minutes. And B will take 64 more than T, that means 80 minutes approximately. Now let's get on to the another example. Now here there is another formula, and this is how we are supposed to find it. A full tank gets emptied in 6 minutes due to presence of an orifice in it. An opening tap which can fill the tank at the rate of 8 liter per minute. The tank get emptied in 10 minutes. So find the capacity of a tank. That means the volume of the tank. Here when it comes to finding the volume of the tank, there is a direct formula which says volume or capacity of the tank is equal to A into B into C by C minus A. So here let's put the values. 6 into 8 into 10, that means 48 into 10 would be 480 by 4. which will give you answer as 120 liter. Simple. Okay. All right. So let's move a little more ahead. But before that, let me just take a break for a minute and we'll move ahead. Just a moment. Okay. So I believe that till now the things are very clear. Though these things are just about filling the tank or getting the work done, how long will the time take in, like it's just about the time and the work done by a pipe or anything, okay, or a man even. That's it. So let's move to the another example which says, sorry, before that, let's move on to something which is there with different formulas. Again, there are formulas. These two topics are full of formulas, wherein every single problem or the way of solving the questions will have a different formula, or altogether it would have a different way of solving it. So yes, let's move a little more ahead and see what is there. Now here, if two taps A and B, if two taps A and B, which can fill a tank such that efficiency of A is n times of B and t takes t minutes less or more than the time more time than B takes to fill the tank. Okay, if there are two different taps A and B are there, okay, such that the efficiency of A is n times than B and takes t minutes less or more than B to fill the tank, then it would be then the time taken by the tank by both pipes together. Okay, if the tank is getting filled by both of the pipes, then it will require the time taken would be nt by n square minus 1. Okay. Second formula would be time taken to fill the tank by the faster tap. Now, faster tap would be here A, and the tap which is slower would be B. So it would be T by n minus 1 minutes. Okay, T by n minus 1 minutes. Now, the third would be time taken to fill the tank by slower tap will be nt by n minus 1 minutes, will be nt by n minus 1 minutes. So here, just to make these things understand, let's get on to the examples so that you'll be able to understand it in a more better manner. So here there is a question which says, if tap A can fill a tank three times faster than tap B and takes 28 minutes less than tap B to fill the tank, If both the taps are opened simultaneously, so find the time taken to fill the tank. Here we'll just put the formula, which was the previous one, this one. Because both pipes are open, both taps are open, so we'll just put this formula, which says nt by n square minus 1. Okay, so n and t. What is n and what is t? Here n would be 28 minutes and t is the 3 times faster. Okay, again let's sorry, n would be 3 and t would be 28 minutes. So time would be t. So here it would become 28 into 3 by 3 square minus 1, which is nothing but 9 minus 1. So the answer would be 21 by 2 minutes. 21 by 2 minutes. And that is it. This much is the time uh, which will require to get the tank filled entirely. Okay, so the tank will get filled entirely in 21 by 2 minutes. Okay, now let's move a little more ahead, and I believe that's the last question of the session about pipes and cisterns. So let's get on to that. Okay. So this question says two pipes A and B can fill a tank in 12 and 16 minutes respectively. If both the pipes are opened simultaneously, so after how much time should B be closed so that the tank will full in 9 minutes? After how much time you should close the tap B to get the tank full in 9 minutes? Okay, so here again there is a formula. This is the last formula. And the formula says required time after which B should be closed would be Y 1 minus T by X. Now Y and X are 12 and 16 minutes and T would be 9 minutes. Okay. So 16 is Y and 12 is X and 9 would be T. So here after putting all of these in the formula, I'll get answer as 4 minutes. So after B, after closing the B, the tank will take 4 minutes. Okay. Sorry, after 4 minutes, the tap B should be closed. Okay. After 4 minutes, the tap B should be closed. And that's it. That is it about pipes and cisterns. I'll be sharing the questions for practice in the Google Classroom. Make sure that you all will be practicing and do make sure that you'll all come up with the doubts, and I would be happy to solve all of them. And that's it for the day. So thank you so very much. Thank you. Thank you guys.